Your parents never told you voting is fundamentally flawed. We trust our democratic voting systems, right? But mathematics reveals a shocking, uncomfortable truth. Economist Kenneth Arrow proved something unsettling in 1951. No perfect democratic voting system can ever exist. This theorem sparked massive academic and political debate. Its implications challenge our core beliefs about fairness. Prepare to question everything about modern governance now. Imagine choosing between 3 delicious ice cream flavors. Everyone ranks their preferences differently, naturally occurring. How do we combine these individual choices fairly now? This is the fundamental problem of social choice theory. Mathematicians have studied this aggregation for centuries. Condorcet's paradox, for example, showed early challenges. Collective preferences can become cyclical, creating indecision. Simple majority rule often leads to inconsistent outcomes. Kenneth Arrow sought to define an ideal voting system. He established 5 seemingly reasonable, fair criteria. First, no single dictator should determine the outcome. Second, all voter preferences should be considered fully. Third, irrelevant alternatives shouldn't change rankings. Fourth, if all prefer it to be, the system must agree. Fourth, if all prefer it to be, single result.
These conditions seemed perfectly logical for any democracy.
Arrow's groundbreaking 1951 theorem delivered a bombshell. He mathematically proved no system can satisfy all 5. Any voting method must violate at least one criterion. This means every democratic system has inherent flaws. It cannot simultaneously be fair, rational, and non-dictatorial. The proof uses rigorous logical deduction, not subjective opinion. It earned him the 1972 Nobel Memorial Prize in Economics. His work fundamentally reshaped economic and political science. Consider real-world elections and their controversial results. The spoiler effect in plurality voting is one example. Third parties can inadvertently shift outcomes dramatically. Strategic voting, not genuine preference, becomes common practice. Voters choose less preferred candidates to avoid worse ones. Different voting systems yield vastly different winners sometimes. Ranked choice voting aims for fairness, but has its own issues. Arrow's theorem explains these persistent, inherent problems. Arrow's impossibility theorem reveals deep, inherent paradoxes. No voting system is truly flawless, a mathematically proven truth. Understanding this changes our perspective on democracy itself. It forces deeper thought on civic participation challenges. Thanks for watching. Subscribe to explore more fascinating stories.